Part 21, Real Numbers. You will find this on page 50 in the Namibian Mathematics Grade 8 textbook, Y equals mx plus c to success. Real numbers. Real numbers are made up of rational numbers and irrational numbers. Every number that is on the number line is a real number. From class activity 4, we discovered that terminating decimals and recurring decimals are rational numbers, but infinite non-recurring decimals are irrational numbers. The following diagram summarizes the types of numbers we have learned in this chapter. Real numbers divide into two groups, rational and irrational. Remember, irrational usually underneath the roots, but don't forget the symbol pi. Now, rational numbers can again divide into integers and fractions. Remember, integers is having no fractions, but it can be negative as well as positive numbers. So, integers divide into negative integers from -1, -2, -3, and so on, as well as whole numbers. Remember, whole numbers. I like to tell my students, whole number is having a O, so that's why it's starting. Counting numbers also having a O, so basically it's going to start with 0, 1, 2, 3. Whereby whole numbers divide into 0 and natural numbers. Do you see no O? So basically it starts at 1, 2, 3, and so on. And then natural numbers divide into 1, and then prime numbers, which is only having two factors, the number 1 and the number itself. So 2, 3, 5, 7, 11, 13. And then all the in-between numbers like 4, 6, 8, 9, they are all composite numbers. This is a nice diagram to know because it helps you to classify the numbers. Okay, let's look at an example. Example 21. I give you a list of numbers, and then I say from the list of numbers, write down all the integers, all the irrational numbers. Now, if you see something that must be calculated, first do that. It's going to help you. So basically, work out square root 5. So if I go and I say square root 5, press it on your calculator. Square root 5 equals, and it will be 2.236067977, and it's going on, so it will be irrational. Let's look at square root 30. Press it on the calculator. Square root 30 equals, what will this be? 5.4772255575, going on, and definitely also irrational. Both of them are infinite non-recurring decimals. And then, oh, this is a nice one. Square root of 36, that will just be 6. So it's actually an integer. So if I say from the list of numbers, write down the integers. Now, this is a fraction. There is an integer, -2. But also, this is an integer. And if I ask you irrational numbers, irrational, there, square root 5, as well as square root 30. I want you to do for me, try now 21. Let's just highlight it. And as soon as stop the video, and as soon as you are finished, you can basically just continue with the video. Okay, from the list of numbers. Now remember, I can see this is rational, I know this is irrational. But always, let's just say, try now 21. I prefer to work out the ones in the roots. So basically say square root 14, and it will be 3.741657387. Oh, and I can see it's irrational. Square root 16, can you see? So if I square it, that's 4, that's an integer. But just press that on the calculator. 65 divided by 13. And what did you see? So if you say 65 over 13, I get a value of 5. Okay, so if I say one integer, I want you to write down one integer. Now look, this is not this, but square root 16 was an integer. So I can either write this one, or, remember this is also an integer, 65 over 13. Don't let them catch you out with a fraction like this. And then number B, one irrational number, no, rational, oh, pi is irrational, square root 14. So, or pi, you can either write pi or square root 14. Rational, rational.